And this is section 3, law of division and derivatives. In this section, we learn the law of dividing a number by a number, and both numbers are in the index form. And what is more, like I said earlier, both of them are in the same base. After we learn that basic law of division, we learn other laws that are based on that law of division. That law of dividing number by number when both are in the same base is primarily what we refer to as law of division of indices. Then those ones we're going to learn afterwards, which are based on that law, are called derivatives of law of division of numbers in the index forms. Before we learn about derivatives, let us first learn that basic law of division of numbers when they are found in the index form. Don't forget that. Before a law applies, the basis must be equal. Now, look at this example. This is both example and a law at the same time. A to the power x divided by a to the power y. We know that there is a way we carry out this division and the answer comes out. In actual sense, what it means is to get this number in its ordinary form and to get this number in its ordinary form and then divide this by this. Whatever you get is the answer. That is the basic thing we are expected to do to carry out this number operation. But when number operations become complicated, not just complicated, when it starts taking long time, a lot of space and energy to write or to carry out, we start looking for short processes. How do we get a short process? It is by observing the long process. After we write the long process twice or 3 times or more, and that is something we observe consistently in all the examples given, it is that thing observed to be consistent that turns out to be law. First, let us give example so that with that example we can prove that this is correct. It says 2 to the power 5 divided by 2 to the power 3. First, let us get the answer to this number operation by the long process. That is, convert this to ordinary form and convert this to ordinary form. Divide this by this. Whatever you get is the answer. Already we have seen that the answer we get is equal to 4. But please, look at the process that led to that 4. 2 to the power 5 means 2 times 2 times 2 times 2 times 2. Then divide by is something as this over. It thinks that over is one of the meanings of this sign. That is why I placed it. Then 2 to the power 3 is 2 times 2 times 2. So this over this means this over this. I hope you are following what I'm doing here. Right now, by applying associative law, we can divide this by this and 1 comes out. To show what has happened, I put a slash to show that they have cancelled. The word cancel does not mean that they have failed, they have stopped existing. To cancel here means that 1 divides the other and the result is equal to 1. The same thing happens here. When these 2 divides these 2, the same thing. This divides this 1, the same thing. So at last we have 1 times 1 times 1. So 1 times 1 times 1. Whenever 1 divides 1, it is equal to 1. In fact, whenever 1 divides anything, the result is equal to that number. Now, it is 1 we have everywhere under here. But here we still have 2 times 2 remaining as the numerator or the dividend. Therefore, when 1 divides 2 times 2, it remains 2 times 2. Is that clear to you, please? All right, let's make progress. 2 times 2 came out of here. If we put this 2 times 2 again in index form, we get 2 to the power 2. If we put 2 times 2 in ordinary form, what we get is equal to 4. So far, we have gotten the answer to this operation. The answer is equal to 4. But let us find out if we can observe anything here. I curtailed the number of times I will carry out this proof because I have seen that if I write this and observe something from it and challenge you to do a similar thing, that if you do it, I'm sure that what you're going to observe is just the same thing as what I am observing here. Therefore, this alone may not be sufficient to prove that what we're going to conclude is right. But I challenge you to carry out similar number operations with view to determining whether the last conclusion we're going to make here is correct or not. Permit me to use this simple or this single example to make deductions. What deductions are we making here? First, this is the number operation, and it has this result, this result, this result, and this result. It means it has 4 results, and any of them is equal to any of them. It means that this operation is equal to this. This operation is equal to this. This operation is equal to this. Any of them is equal to any of them, since the statement is clear. Let us isolate this one, equating it to this one, so that here we have 2 to the power 5 divided by 2 to the power 3 is equal to this one. See it here. This is a deduction made from this place. Therefore, 2 to the power 5 divided by 2 to the power 3 is equal to 2 to the power 2. Therefore, check these 2 and check 5 and 3. The base remains the same thing, 2, 2, 2 everywhere. But how these 5 and 3 became 2 can be worked out. We can deduce that this 5 and 3 became 2 by saying 5 minus 3. That is to say, 2 to the power 5 divided by 2 to the power 3 is equal to, instead of writing this 2, I explained how we got the 2 by saying 5 minus 3. That is this 5 minus 3, which means this 2 came by saying 5 minus 3. In other words, if you prove that this thing I observed here is right, we then conclude that a to the power x divided by a to the power y is equal to a raised to the power x minus y. Is that clear to you? Anyway, let us see examples that will conform to this operation. And there we go. Example A says 10 to the power 4 divided by 10 to the power 2. First, let us find out if we are correct with respect to this law we give here. 10 to the power 4 is the same thing as 10,000. 10 to the power 2 is the same thing as 100 when converted to ordinary form. If we divide 10,000 by 100, what do we get? I believe we're going to get 100. And that 100 is the same thing as saying 10 to the power 2. Therefore, instead of moving through the long process of first converting this to ordinary form and this to ordinary form and later dividing, we just follow a trick. A trick is in this law. The trick is just subtract this from this, and that becomes, the result becomes the power of base 10. And that leads us to 10 to the power 2. Please confirm that this law was used well here and that it is correct. All right, because this is ordinary number, it can confirm the usefulness and veracity of this law. But when it comes to use of variables, we only use the variables and apply the law because we have known that the law is correct. It is not going to be so easy to use non-constants like these ones to confirm that this law is correct. It takes constant operation like this to confirm such. We can therefore take this example 2, example 1, please, to further confirm that this law is correct apart from this one we used in the beginning. Now let's make progress. Example number 2 goes this way: x to the power minus 1 divided by x to the power 2. Look at this law. Our a is now x. Our x is now minus 1. Our a again the same x here. Our y is now 2. So what then will be equal to x minus y? Remember that this x already has minus with it, so it's going to carry it wherever it goes. Next, we have the same x raised to the power minus 1 minus plus 2. This minus here is the one we have this place. This minus we have here is the one here. Then this 2 has no sign before it, but we know that plus is there. Whenever a number is written and there is no sign written before it, the sign it should have is plus. Therefore, we conclude that this 2 is plus 2. I hope you now know why minus 1 and plus 2 are the way they are in this operation of powers. Surely you do. That's what I believe. Now, minus 1 minus plus 2. What will it give us? First, we have to use this minus to open the bracket. We call it negative of having 2. That is owing to. That means that if you open this bracket with this minus, you now have this minus. Minus 1 is still where it is, see it here. And when this opens this bracket, one sign minus becomes the result. So that the whole of this operation simplifies to minus 1 minus 2. If you are confused as to how this became this, despite my brief explanation, please go back to the topic I taught earlier, principles of mathematical operation. You're going to get more facts. And if you come back here, you see how easy it has become. Further, minus 1 minus 2 is equal to minus 3. This is not multiplication. If this is multiplying this, the answer would have been plus. Or if this is dividing this, the answer would have been plus. But we are adding them. So we now recall that it is not everywhere you see minus minus that you call it plus. Again, refer to principles of mathematical operations. Therein, you get more facts that will come back, that will make you come back here to see it as a cheap operation. Eventually, this means I'm owing 1, I'm owing 2. Because we are adding them together, I'm owing 3. In other words, the whole thing is equal to x to the power minus 3. All right, example C goes this way: y to the power minus 2 divided by y to the power minus 6. What happened here is going to happen here again. This a is our y, this x is our minus 2, this y is our minus 6. So x is already minus, y is also already minus. Let's see what happens. Y to the power, this is minus 2, see it here. Then this minus is the minus which appears in the law, see it here. Then this y is minus 6. See minus 6 here. I hope you now know why this expression is the way it is. Next, minus 2 minus 6. Because a bracket is here, we are not adding this minus to this minus 6. Instead, we are multiplying them. I don't mean to multiply minus 6. Minus 2 is on its own. So you use this minus 1 here, hidden, but minus is there, written. It now has to do with, it now has to be said to be negative of owing 6 is having 6. So minus 2 is still where it is. Then when these two combine, by interpretation, as we had measured a while ago, it becomes plus 6. So we have minus 2 plus 6. Owing 2 and having 6. After reconciliation, that is after counting, we have 4. Because of that, this operation yields y to power 4. The last one says c to power minus 3 divided by c to power minus 5. The same thing happens here. Minus 3 minus bracket minus 5 is equal to, please, if you open this bracket, what will it be? Plus 5. Perhaps by now, you should have known what is happening here. So minus 3 minus minus 5 is equal to minus 3 plus 5. And I'm owing 3, I have 5. So if I pay the 3, I should still have 2 left with me. And that's why the answer is equal to c to power 2. Therefore, c to power minus 3 divided by c to power minus 5 is equal to c to power 2. At this point, please, check whether you can solve the following after listening to my explanations. And that's the checkpoint. It says evaluate the following operations via law of division of indices. The first one says 5 raised to the power 4 divided by 5 raised to the power 7. Number B says m raised to the power minus 2 divided by m to the power 2. Number C says g to the power minus 1 divided by g to the power minus 4. The last one, that is number D, e to the power minus 3 divided by e raised to the power minus 8.